So let us now see customizing of input output in C++. We'll talk about input and output and numeric output like integer and floating point. Then various file modes like binary input output. Then positioning in file, string streams, line oriented input like character input and character classification. There are various kinds of input like individual values, streams, GUI graphics, text like type driven, formatted, line oriented and individual characters. Also we have numeric like integer, floating point or user defined types. So as a programmer, what we prefer is regularity and simplicity. But what is our job? Our job is to meet the people expectation who has given us the job, to make something for them. But one important thing is the presentation has to be very good. The thing which look good sells more. So there are various rules like these things. What does it mean? How do they look? What does they present? So the world is is like that. You and me are also like that. We always want that things should be good, they are formatted and pleasing to us. So integer values like 1 2 3 4, this is in decimal, this is in octal, this is hexadecimal. Also we have floating point values, this is a generic or general floating point values, while this is scientific. It's a huge number, so usually we use e exponential for this. This is fixed. But what is the precision for floating point value? What is the precision? You count this 1 2 3 4 5 6. This is the precision. In this it will be 5. What are the fields? This is default for 1 means 1 2 and followed by this pipe, so 2 pipe. So 12 1 2 in a field of 4 characters. Okay, this is how you have 1 2 means if you have a pipe, or you can say it's a space. So whether you want to write 1 2 in this manner, present in this manner, or 1 2 in this manner, this totally depends on you. How do you want to format? You have numerical base output as well. You can change the base like this. This is base 10, you call it decimal, base 8 you call it octal, and base 16, this after 9 you will get A, B, C, D, E, F to represent 10, 11, 12, 13, 14, 15. So let us see or present you with a simple test. Like if you want to present DEC and 1 2 3 4, you can have this 1 2 3 4 with some slash t and slash n. Slash t is going to give you a tab, means a space, maybe it's generally 4 spaces, and slash n is new line character. This is tab character. And if you want to print hex, then it will be 1 2 3 4 and awk 1 2 3 4. So what this is going to do is, when it is going to be printed, this code or this statement, this is one line statement only, when it is going to be printed, this will be printed in this format. You see 1 2 3 4 for decimal is this you'll not have any trouble in viewing this, but understanding this will be somewhat you need to know how decimal representation, hexadecimal representation and octal representation are there. So this is octal representation, and see the formatting also, because of slash t and slash n. Slash t is this space, slash n will give you each line in a new line. So this looks quite pleasing to our eyes, and this is how people would like to see it. There are sticky manipulator also. What are they? Our same example like this. Let us take an example. Same example we have tried, but what exactly this doing is, you have 1 2 3 4 as what we would expected. But what about this hex 42? It was converted to 42, and also this one. Then again you printed this. The octal base is still in effect because this is oct. 1 2 3 4 1 2 3 4. But now these are the result that nobody could understand. This program nobody is going to see because this is the program. The output will be actually this. This is what is the feed. This is what is the lunch. The ingredients are this. One more thing, that same example will take with 1 2 3 4. I'm trying to print hex and octal, and also end line. End line is exactly same as slash, and they are synonymous. They are equal. They both do the same work. Now we can have something printed called show base, DEC. This show basis. Now after this, what you can do, 1 2 3 4, then it will be converted into hexadecimal, and then will be octal. In this case, what it is going to do, after 1 2 3 4 with a tab, it will be going to show you hexadecimal and then octal. Okay, so this is how you can very well use your manipulators and things which are changing by manipulators. You have floating point manipulators as well. You can change this floating point output format. One is your default float like IOStream, which chooses best format using your n digits, which is default. While in scientific, one digit before the decimal point plus your exponent, which is n digits after, and after dot, n digit after this dot or decimal. Then fixed means no exponent, n digit after the decimal point. How you are going to show it? Let us take an example. This is the value 1234.56789. You want it to be printed as default float, and you can also give /t how many times you want, just to show them a little pleasing. So in the default default float, what it is going to do, it will be presenting you 1234.57. What it has done, chooses best format using n digit. This is the default. So 6789, it sees that what comes after 6, it is 7, so it will increase this 6 by 7. This is default float. Once you want it fixed, means whatever is there, it will be printed. So you will be presented with the same stuff which is being shown here, 5 6 7 8 9, and depending upon n digits, you will have some zeros also being padded. In order to show a scientific value, as I just mentioned, that the scientific value will be something like this: one digit before the decimal point. So one digit before decimal point will be like this one. Then will this between 1 and 2 there will be decimal, and after that one digit before the decimal point plus exponent, and n digits after dot. So you'll have these digits 1.234 5 6 7 8, and depending upon this n digit, it will show you and into 10 to e to the power 3. So once you multiply this with this one, ultimately you will be getting this value only. So this is how it is represented in scientific way. But there are precision manipulator also. Like precision, the default is 6. The default float precision is the number of digits. Then in scientific, precision is the number of digits after the dot. And in fixed, the precision is the number of digits after the dot again. Let us take example 1 2 3 4. This value 0.56789 /t, just to show it pretty. Then you have this fixed. So you want to show it as fixed. Which one? This one. This you want to show it fixed, and then you want to show it in a scientific form. Same stuff. As you can see that in default it will be converting this 6 to 7 because this is greater than 5. Value greater than 5 will be incremented, the previous value will be incremented, and value, if this value is less than 5, this value will not be incremented, it will remain as 6. In this case it is 7, so greater than 5, so it will be 5.57. Once you want fixed, it will be giving you fixed value. I told you already how this fixed will be shown. In scientific, I already told you that 1.12345 so after this precision you have 12345 because the default is 6, the precision is 6. Again 12345 because the precision is 6, so after decimal you will find 6 value. This 0 is padded. Okay, and okay, this is fine, this is your default. But what if you like to show, or you want only precision as 5? So what you can have is, you can just write general and then set precision 5, and same value, same 3 values will be printed. But here this you already know, because 1 2 3 4 5 only 5 value will be printed, and this 6, now this 6 will convert this 5 to 6 because this is more than 5. So this will be 1234.56, and this one will only have these 5 precision. So it will be 1 2 3 4 5, again 1 after decimal 1 2 3 4 5, and then exponential. Same with the precision 8, same with the precision 8. Then you can also have some output field width. So the width is the number of characters you want to use for the next output operation, but you need to be sure that width applies to next output only. It doesn't stick like precision, base and floating point format. So you have to use this for next output operation always, because it is going to stick with that. And output is never truncated to fit into field. This is also with your if you want some precision of width. So how can you do this? 1 2 3 4 5 6 is okay. Now you want set width SCTW 4. 1 2 3 4 5, between these 5 1 2 3 4 5 will be shown. And if this set width, again you have to do it for 1 2 3 4 5 6. So hope I can tell you, and I can show you that there are 1 2 3 4 5 6 these are the digits, or these are the numbers, but you have 2 spaces also here. That is why 2 spaces will be there, and in all there will be 8 spaces. And again for 1 2 3 4 5 6 there will be no set width. You have to do it again for this 1 2 3 4 5 6. So there will be no change, it will be printed just like this. And in this case also, if you want set to show this, it will be shown directly. And if you want set width 4, no problem, because this will show you whole number. But in this case 8, because since there are 1 2 3 4 5 6 numbers only, so 2 will be shown here. Or rather because there is a decimal, so only 1 space will be there. One space will be taken by dot, because dot also is a token. And again in this set width I can show you more. You know about this, but because this is a string, so A, S, D, F, G, you want 8, so this is 6, you have 2 spaces here, right? So this is how you can output field width. Since this kind of detail, what you want to show in your textbook, manual references, this will always be there. And sometimes you may forget them, but no problem with that. You can show your code in a beautiful manner, but just by using all this stuff. So we'll be talking more about this. Thank you so much. Take care.